So in this question, we have a particle which is projected with a velocity u. It makes an angle like theta with the horizontal. As you can see, this is the velocity component. This is the velocity vector u, and theta is the angle with the horizontal. This is our x-axis. This is y-axis. So at any instant, the velocity v is at right angle to its initial velocity u. At some instant, now we have to determine the magnitude of v, the velocity of v, the velocity v. So from this particular figure diagram, we have to conclude, or we have to think that the velocity, so let's say this was initial velocity, so the velocity v can be perpendicular to the initial vector u only in this portion, means after this highest point. It cannot take place before that. You can just think that if you start plotting this velocity like this, like this, like this, only in some portion of this trajectory it will be perpendicular to u. So at this point, if that will be the case, then what will be the situation? It will look like this. So this will be our initial velocity vector and v will be perpendicular. So these are our x and y axis that we had drawn earlier. Now if let's say we know from the geometry that if u is this and our v vector is this and they are perpendicular, then so if this is the theta angle, okay, then the angle so this angle and this angle, they also have to be theta. Okay, I think you got it, because this is the very basic theorem. You can also prove it. So if that is the case, so if you start making components of this velocity vector, then what will be the components? The components will be, so this v, it will have an x component, it will be like v sine theta, and another one will be this one, and this will be v cos theta. So one thing in projectile motion we know is that in whole trajectory, since acceleration due to gravity, it always acts in a downward direction. So let's say, so it was the initial x component of the velocity, so it will remain unaffected, while this y component, it will be affected by the acceleration due to gravity. So at this highest point we will have only the x component, so this will be the x component that will remain as it is. So by applying that basic concept, what we can think right here is that this component v sine theta will always be equal to the initial x component of the initial velocity, that is u of cosine theta. Okay, now from this we can write v equals to u cosine theta upon sine theta, and this is u cot of theta. So this is our answer. Now this has come from very basic concept. There is nothing fancy about it.